Hello, in this video tutorial I will discuss about spanning tree protocol or STP. So what is STP? Well, STP is an older network that ensures loop-free topology for any bridge Ethernet local area network. It achieves its primary objective of preventing network loops on layer 2 or switches by monitoring the network to track all links and shut down the redundant ones. STP uses the spanning tree algorithm to first create a topology base and then search out and disable redundant links. Or you can manually set the priorities so you can elect the root bridge manually. With spanning tree protocol running, frames will be forwarded only premium STP chosen links. Let me give you an example here. Okay, I will discuss in the next few slides about what it means by this spanning tree protocol. Notice that if we don't activate the spanning tree protocol, these frames will keep looping and never stop. So with spanning tree protocol, we're gonna block one of the port. For example, we're gonna block this port, then we will not have any broadcast storm. Okay, so let's continue on the presentation. The next thing that I'm gonna talk about is the terms. Okay, before I move on to the presentation, I want the student to be familiar with some of the terms. Okay, what is root bridge? Root bridge is the bridge with the lowest cost and therefore the best bridge ID. Okay, the bridge ID is how the STP keeps track of all the switches in the networks. Okay, and the root port is the link with the lowest path cost to the root bridge, and a designated port is one that has been determined to have the best and lowest cost to get to a given on a given network segments. Okay, so what is a bridge ID? Okay, let me show you this one. You see that in this switch you have priority. The default priority is 32768. Okay, and the root bridge ID is this one, is 000.0CA7.A603. The first octet represent the bridge ID and the last two octets represent the MAC address. This is in hexadecimal number. Okay, so if you don't know how hexadecimal works, make sure that you watch my previous videos, or I will discuss that in the Blackboard. Okay, so the bridge ID is used to elect the root bridge in the STP domain and to determine the root port for each of the remaining devices when there is more than one potential root port available, because they have equal cost path. Okay, for example, notice that in these two switches you have priority 32768, and also switch B also has the same priority value, which is 32768. So these two switches has the same priority. So next we need to look at the bridge ID. Remember, the bridge ID consists of the priority number and the MAC address. Okay, so 000.0CAB compared to this one, switch B is 000.0CF6. This one has the lowest bridge ID number. 0CA is smaller than 0 CF. Remember, hexadecimal is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then A, B, C, D, and E. E is E and F, right? F is 15, 14 is E. Okay, so make sure you learn the hexadecimal number in order to understand this slide. So this key bridge ID is 8-bit long, 8 bytes long, okay, and include both of the priority and the MAC address of the device as illustrated in this figure. Remember, the default priority on all the devices running the IEEE STP version is 32768. Later on, we can lower the priority number in the next slide. Okay, so this bridge ID is below the priority. Okay, so first, in the spanning tree protocol topology, first we have to look at the lowest cost of priority. If they are in equal cost, then the next thing you need to look at the bridge ID number. Okay, the lowest bridge ID number, then that will be the root bridge. Okay, let me see. Okay, the next one. Okay, so these are some of the steps to obtain a loop-free environment in the switch network. First, find the root bridge by analyzing the priority ID and or the bridge ID, as we discussed earlier in the previous slide. Okay, this one. Okay, the priority or the bridge, right? All right. Port priority can be set up manually. The default priority is 32768, but we can lower it if needed. For example, we can use a command line in the switch and type this one: spanning tree VLAN 1, for example, priority 4096. Since 4096 is lower than the default value, so this will be the switch with the priority, with the lowest priority number, will be the root bridge. Okay, if you want to increase the number, you have to increase by this number, 4096 multiplied by 2. That is the next priority number. So you cannot just add any random number. It has to be in the multiplication of 4097. Okay, that's how you set up the priority manually. The next thing is how to determine the root port by finding the lowest path cost. Okay, 100 megabit per second link costs 19, 1 gigabit per second costs 4, and 10 gigabit per second costs 2. So if you look at this one, 1 gigabit, this is cost what? 4. So if in this diagram this is 100 megabit, so the cost is 19. All right, that's what it means by the lowest path cost. Okay, after you find the root port, then we need to discover the designated port by looking at the bridge ID. Okay, the last step is the leftover port will be the blocking port. Okay, so this is some of the concept that we need to understand before we actually go into the real one here. Okay, so let me stop here. Let me continue in the next video.